Hey guys, today is my second video putting out there on YouTube, and today we'll be going through polynomial regression. Okay, everyone know regression. So now, what is this polynomial regression? It's nothing but linear regression with ordered features. Okay, so now there's a lot of questions here. How come polynomial regression is a linear regression with ordered features? How? So see, these added features, these are not something out of the box or something like that. No. See, while working with our linear regression model, we are having our input data set X. So these added features means we are this X, this input, original input value we are having, we are just mm, ma- like playing with it or manipulating it. Okay, making it like something like x squared or x to the power 100 or x to the power 30, something like that. Okay. So it's the same input features, but here it's being squared. Here the same input features, but it is raised to the power of 100. Here it is raised to the power of 30. Right? That's it. So now there's two different questions here. Now, first one, why do we need these features? Why do we need this features? Like, what's the use? And the second question is, why the name polynomial regression? Right. So see, we know the like I'm trying to talk about now. Here. So this is what our linear regression model looks like, right? We are having data points here and there. This is our slope or the weight, W. This is Y. This is X. Correct. And this is what the equation of linear regression looks like. Wx plus d. That. The flaw here with linear regression is that it as the name suggests, it's linear. Okay. What happens is that it assumes a linear relationship for the data sets. And in real life cases, the data they are not linear. Okay. In real life, data are not linear. We know this. So to make this line, instead of letting it be a straight line, to like kind of bending it, so maybe something like this or something like this. Okay, it's just weird. Okay, yeah. I hope you're getting my point. Okay, like basically bending the line, making it a curve to cover more area. In simple terms, to cover more area in our data. How do we do it? We just basically simply manipulate the input data by raising its power. Okay. So that's why we need these switches. If we don't do, what will happen is that if we just stay with linear regression, stay with linear regression, our model will underfit, will underfit. Underfitting means, in simple terms, having less knowledge. Having less knowledge. Okay. So to make a model, like to make a model more accurate, we go with this polynomial regression. But there are two major problems with this. First one is gradient explode. Okay, I will write it in the next page. Okay. Now there are two problems with polynomial regression. First problem number one. So problem number one is gradient will explode. Gradient explode, yeah. Okay. Not always gradient explode, but yeah, there are like pretty good chances that the gradient will explode. Now, second one is just second one. It's like, how do I put it? It's like it's very weird. Like we can say it's overfitting. So what is overfitting? Overfitting is the opposite of underfitting. Okay, overfitting is like the opposite of underfitting. So it's like a very weird thing. I literally had this question while learning this thing. So I was like, okay, underfitting is something, it's like having less knowledge, like in simple terms. And due to this underfitting issue, have come up with this polynomial regression so that we will know more. Like our model will be more accurate, right? So if that's the case, then how come there is a overfitting issue, right? So see, I will just use the very simple example. Okay. So we know we need to learn maths. Okay. If we are starting our journey with AIML, so we know the basic is learning the ba- basics of AIML. The first thing that comes is maths, right? In maths, there is calculus, statistics, and probabilities, right? And linear algebra. But the thing is that the basics of mathematics needed to start with AIML, they are not at rocket science level. They are not at something that of physics professor or a rocket scientist or, or some big like scientist that are working on complex problems, right? Or the s- space space research, something like this. Okay. So there we know that these concepts we use there at a very high level, right? But we don't need to know this concept at that high advanced level for AI. We just need to know few basic topics here and there and we are good. But the thing is that it's not bad to know those are advanced things, right? But if we put our mind into knowing those are advanced stuff that are not really needed for AML, what will happen is that it's a good thing that we will know more, but the thing is that we will forget our end goal. What is our end goal? It's learning AIML, it's researching on machine learning algorithms, models, optimizing them, right? Our goal is not to become a rocket scientist or space scientist, right? So we are kind of like forgetting our goal, correct? So th- that is what overfitting is. So our in terms of our ML model, if we see overfitting memes, we are like, okay, there, there's a lot of noise that we catch. So suppose this is our data set, okay, and mm, suppose this is the graph we draw. For example, I'm saying this is the line we are kind of considering to go with, okay, as it is having more coverage and it is much more efficient than the other ones. But as we can see that it's covering more area, it will also calculate, sorry, it will also, please ignore my handwriting. It will also pick up a lot of unnecessary stuff that we can classify as noise, correct? So this thing, they will also be processed and calculated by our model, right? They will also consume up the sources and the hardware stuff. What will happen is that uh, they will make a model less efficient because we don't need those datas, correct? So to tackle this overfitting issue, we perform regularization. So there are a lot of ways for regularization, but mostly are L1 and L2 regularization. One is reads, another one is lasso. Uh, the regularization is a separate topic in itself. So if I will explain this in this video, then it's going to be more like almost a 1 hour long video. So yeah. Mm, Now coming to this gradient explode concept. Okay, what is this thing? So to gradient explode, as the name suggests, gradient explode means our gradient will kind of go out of its way or bounce and bounce. Now, what is this? Okay, so see, suppose we are having a data set. Let's say 2, 4, 8, 9, 10. Correct. And we are making it x square. So x square will be 4, 16, 64, 9, and 81, 10. Okay. So see, for example, this 10 and 100, there's a lot of difference between this value, right? Like 10, 100, 90 points difference. 9 and 81, 72 points difference, right? It's a huge compare, right? So gradient exploding wise, suppose we are performing our calculation and after performing our calculation or being done with our current iteration for gradient calculation, we came up with an error value, suppose let's say 0.09. Suppose if we multiply this 0.01 with 9, for example, I'm saying 0.01 into 9, what will happen is that it will become 0.09. It looks like a very small value. So if we decrease our gradient by this value, then our gradient is definitely not going to explode, right? It's a good value. But the same error value, if we are going to multiply with 81, that's the square of 9, it will be 0.81, correct? So for the moment, let's compare these two values. It's a huge number. So our gradient, it will like kind of decrease by a huge number. So there will be a massive drop in our gradient. So we cannot have that. Now, how do we tackle this? Right. So you can say that as 9 is a small number, its power or its influence is less compared to that of this 81. It's a huge number, so its influence is high. Now, how do we need to do something about it, right? So that both of these value will be of equal importance, because at the end of the day, 81 is something that is coming from 9. Okay. So what do? We standardize this data. The concept of standardization. Okay. So standardization, like regularization, is a big concept in its own. So I will explain it in this regularization and standardization. I will explain this in some other videos. This video, if I'm will explain this standardization, it will take more 15 to 20 minutes. Okay. So what standardization does is that it makes sure that all of these values, x and x squared, both of these values, they have equal influence, they have equal voting rights with them. So I I will just say standardization on like this is what it looks like. So we have our x value. So suppose this is what our x looks like. Our input features 60, 75, 80, 85. Then comes the 90. Our x square looks like this. 62 squared is 3600. 75 squared is 565. 80 squared is 6400. 85 is 7, I guess 225. Yeah, 7225. 90 squared is 8100. Yeah. So, so standardizing them. After standardizing them, uh, we have a mean as 0 and standard deviation as 1. Okay, this is what we can expect. So what happens is that x will look like this: minus 1.4, minus 0.2, then 0.2, then comes 0.6, then comes 1.8. X curve will look like this: minus 1.5, minus 0.3, 0.1, 0.7, and then comes your 1.3. Now, if we compare both x and x square, we can see that they are pretty much same with each other, right? So they have pretty much the same voting or influence, right? So this thing will help us stop giant exploding, correct? Yes. So now there's a step-by-step procedure for this walking. So for polynomial regression, this is step by step. First thing is we obviously collect our data. That's the basic thing. We collect data. Okay. We pre-process it, like remove the null values. Okay. Removing null values, then properly arranging them, labeling them and all. Okay. Proper arrange, labeling. That's it. Then comes the step two. So see, this is the very important step. We standardize our data. Okay. Uh, do know one thing. You might ask me that why can't we do regularization here? We can do regularization here, but the thing is that that will be worthless, because if at this step we do regularization, then we will be having pretty big numbers here, right? If we don't standardize our data. So if we have pretty different numbers, like they are, um, not fair with each other. Some number is having a high influence or voting right because it's a huge number and the other one is not having, then there is no point of regularization. So therefore, first we standardize our data. After standardizing our data, then we regularize it. Okay, regularize the data. Then after regularizing our data, we predict or like model warple. Mm. Okay. Then we obviously calculate our pre- prediction happens. After that, we calculate the error, correct? Then we get some value, and like this it goes on. So that's it. This is how the whole thing works. Now I will give you a sample code here. Just a second. So see, this is a sample code. Uh, Here we are defining our input x. Okay, and here we're just defining random values and all. Okay, it's a sample code. It's yeah, and our expected y, the actual y, expected y. Y means the output finding. The right? Here we are splitting our data set. Correct. Now this line, what it is doing is that it's defining the polynomial. Okay, relation. Define the polynomial. Okay. Here degree 2 is 1. So it's a 2-degree polynomial. Okay. Then we are putting the training and testing data. Okay. After that, given the training and testing data, here we are standardizing the data. After standardization, here a regularization is happening. Then we are predicting now values, calculating their values, and yeah, that's it. And here the plotting is happening. So it's a simple code. Okay, it's just to tell you like how they work step by step. Okay, how they work step by step. That's it. It is just a simple code. Uh, yeah, that's it. And thank you for watching. And in next video, I will explain about the concept of standardization and regularization. Okay, so thanks. I know there's like it's still I'm like it's my second video and yeah. Um my handwriting it's kind of a mess. I know when I write it on the copy, it's like I'm actually writing it with a pen. It's not bad. It's a good handwriting. But yeah, I'm writing it electronically, right? So it's like I need some time to be properly like to be able to properly write this thing because honestly, initially I thought I'll be able to write it, but it's like it's a different thing, man. So yeah, thank you.